Okay, so now we're going to talk about the fundamental counting principle. So the fundamental counting principle uses multiplication instead of a tree diagram to determine the number of possible outcomes of an event. It is a shortcut to find the number of outcomes, but this is important, so I'm going to underline this. It will not tell you what the combinations are. So if you look down here at the Yummy Steakhouse, we have 4 different types of steaks. We have 3 different ways they can be cooked. And then we have 4 different types of potatoes. So you multiply, 4 times 3 is 12, 12 times 4 is 48. So you have 48 outcomes. So that's a lot easier than making the tree diagram. The issue is you don't know that somebody got a New York strip and they got it medium well and twice baked potatoes. The only thing you know is how many different outcomes there are. Example 2. Okay, so ice cream sundaes come in 2 different sizes. There are 5 flavors of ice cream and 4 different toppings. So 2 times 5 is 10, 10 times 4 is 40 outcomes. Okay, so a gene factory has all these different sizes here and then 3 different lengths. How many different sizes of junior genes are there? 1, 2, 3, 4, 5, 6, 7. So number 1 is 7. Number 2, how many lengths? 3. Find the product of the 2. So 7 times 3 is 21. Then the next question says to make a tree diagram to compare. Why don't you try that and then check your work with me? Okay, so I abbreviated and I used P for petite, R for regular, and T for tall. But here's 3, 6, 9, 12, 15, 18, 21. So, using the tree diagram, we got the exact same number of outcomes from number 3. But the issue with number 3 versus number 4 is number 4 you can see every single outcome. Number 3, when you just use fundamental counting principle, you just know how many outcomes there are. So now you might remember from your SOL, the practice SOL you had the other day, there was a question that said that you have a 3-digit combination that could have numbers from 1, 2, 3, 4. Then it asked you how many combinations there were. So I gave myself these 3 blanks here that represent the 3 digits. So if you could have 1, 2, 3, or 4 here, same thing here, same thing here, how many outcomes are there? Here's 4, here's 4 more, and here's 4 more. So it gives you 16 times 4, which is 64 outcomes. Okay, so now spend some time and be sure that you get the practice pages complete too.